Got to give the people. Give the people what they want. Bass, I'm here talking about logarithms or logs. Write this down. So logarithms, logs. Log equations are another way to represent exponential equations. We're going to talk about how to use them and whatnot in a bit, but right now you got to understand like what they are and how to kind of translate and understand what they're saying. All right? So we're going to take this exponential equation, we're going to translate it into a log equation. All right, we're going to see how this works. So let's take something like the equation 5 squared equals 25, right? 5 to the second power is 25. If you have a log equation, right, I would write that same thing as the log base 5 of 25 equals 3. Right? So this is important, right? I see my base. I see my base. And the way that you say this is log base 5. That's important. If you can remember that, you always know you're talking about the base. Now the thing about logs is logs help us find the missing exponent. The answer to a log is the missing exponent. Actually, I'm going to write that right here. The answer to a log is the exponent, right? And that is the key. The answer in a log is always the exponent. What you're normally looking for is not that. Logs help us find missing exponents. So in this situation, right, if I have the log base 5 and the answer with this missing exponent is 25, right? The thing that I don't know, so my answer is 3. This was the exponent. So this is the exponent of base 5 that would get me to 25. Right? 5 to the third is 25. And that's kind of weird. You got to really think about that for a little bit. Because really, we're used to 25 being the answer. But now the answer is not what we would typically think the answer is. The answer is, what is the exponent on base 5 that would get us to 25? Which is 3. All right? So let that sink in for a second. And we're going to do a couple more of those. Because it took me a while just to get used to that. And I literally have to say the stuff out loud every time I'm doing it. And maybe you guys are smarter than me. You probably are. But we'll go with it. All right, so let's say if I have this exponential equation and it says 2 to the 4th power equals 8. Okay? So the log equation of this thing says, okay, so I always know log, and I always know log, say log base something. Well, this is log base 2. And I write it in a subscript like that. Log base 2. I know my answer is going to be an exponent. So what is the exponent? The answer is 4. So log base 2 of 8 equals 4. Meaning 2 to what exponential power? 4 gets me 8. So the log base 2 of 8 is 4. All right? See if you can get this one on your own. So this one says 4 to the 3rd power equals 64. Go ahead and try to write the log that would go along with that. Pause it. Cool. You just did that. So now you're thinking, okay, I say, okay, well, this is the log, my base is 4, so this is log base 4. I know my answer is an exponent, so when base 4 gets me to 64, I need to know what is the exponent. It's 3. Let's do another one of those. I think I got one more here. Did we do 8? Yeah, we did that one. Let's go right? I know it's a log. I know we're talking about base 6. I know my answer is the exponent, what I'm ultimately looking for. So when base 6 gets to 36, what is my exponent? And that is 2. So, all right, those are logarithmic equations. All right, you're going to get practice with this. Okay? Why use log equations? So why would I want to use these logarithmic equations? And we're going to write logs are cool. Logs are cool, guys. They're cool because they are somewhat, I don't think this is official, but we can use them in a way that makes them somewhat like operations that undo, this is important, they undo a base. I can use them to undo a base and an exponential. And we're going to talk about, well, why would that be important? We'll do it with a couple of examples. So for example, we did that base busting thing in the last class, which is actually today, but we can solve those way faster by using logs. Instead of like changing the exponentials to make the bases the same, we can use these logs. So let's say what if I have 10 to the x plus 3 equals 100. And I'm going to solve this, okay? Nice part about this is I can do the base busting, which I can do, but my calculator will do a lot of the work for me. So, what I know is, I don't really want this x plus 3 to be here in the exponential part. I want it to be in the regular piece of my equation. So I actually want to get rid of this base of 10. The way that I can do that is by using a log 10. So I can say log base 10 of 10. The key here is log base 10 of 10. Those cancel each other out. So I'm now left with this side with just x plus 3. That's what I want, because I can solve that. It's not in the exponent anymore. We've gotten rid of that base and we've brought it down. But on this other side, I have to do the same thing. Now I actually kind of need to move this 100 over, because if I took a log base 10 on this side, I have to take the same log base 10 on this side. Nice part is, log base 10 of 100, I can just put that in my calculator. So I can go to my calculator here, and I can say, let me take 100 and do log 10, and I get an answer of 2. Right? Now what happens is I just have to solve this. Minus 3, x equals -1. Well, let's see if that makes sense. Let's go back to our original problem. It says 10 to the x plus 3 equals 100, right? We just said x is -1, so 10 to the -1 plus 3 equals 100, which means 10 to the 2 equals 100. 10 to the second power is 100. That actually worked, okay? Let us try another one. It's kind of like an inverse operation, right? If I wanted to get rid of addition, I subtract. When I want to get rid of multiplying, I divide. When I want to get rid of an exponent, I take a root. When I want to get rid of a base, I take a log. Okay? So let's try this next one. Let's go 10 to the 2x minus 1 equals 1,000. Alright? So again, I don't want to get rid of anything here. I want to get rid of this base of 10. So the way that I do that is I take a log base 10 of 10. Those cancel. I'm left with 2x minus 1 equals log base 10 of 1,000. I can plug that into my calculator. So let me see what log 10 of 1,000 is. 1,000 log, that happens to be 3. Now I know that 2x plus 1 equals 3. minus 1, excuse me, equals 3. Plus 1 plus 1, 4 equals 2x, divided by 2, divided by 2, x equals 2. Let's see, does this actually make sense? 10 to the 2, does that equal 1,000? Well, 2 times 2, excuse me, 2 times 2 is 4, minus 1, that means 10 to the third equals 1,000. That, again, is true. Now you might be wondering, Bass, why are we just talking about base 10? Because your calculator only has the button to use base 10. We're going to find out how to use your calculators for other bases, but I wanted to give you 2 examples that you could actually calculate right now. But I could do this in the same way. Let's say if I had base 4. If I had 4 to the x plus 2 equals 256. Again, I got to get rid of this base 4, so I'm going to say, I don't know why I write it like that. I know I'm going to need space. 256. I'm going to say log base 4. And to get rid of this, I'm going to do the log base 4. These cancel. I'm left with x plus 2 equals. Now this, as it sits right now, you do not know how to calculate that in your calculator. You're going to learn, I think, next class how to do this. But ultimately, when you learn how to do the log base 4 of 256, it's going to give you some answer. And whatever that answer is, you're going to just pretend like it was 3, and then you're going to finish solving it. I don't even know what that answer is off the top of my head right now, but it does have an answer, and there's a specific way you can calculate it, but we're not learning that way right now. But we would use it in the exact same way. So, that's my video on logs, what they are, how to translate them, why we're going to use them, because they help us solve equations, they help us get rid of bases. Man, I gotta go to my list. Who I gotta shout out? Now, I don't even gotta go to my list because I owe this man. Old man Graydon. I see you. Where you at? Alright? That's my shout out to you, and a special shout out. If you actually watched this video and you want to get a 4, you gotta, I'm really looking hard for this. When you showing me your notebook, you're just gonna put your fingers like this and put the 4 on it. Like, I looked at the video, Bass, all the way to the end. Give me that 4, son. Give me that 4, son. Alright? That's what you gotta do if you want a 4. If not, you get a 3 because you cheated and you didn't go all the way. I'm out.